Hello everyone, my name is Brant Kudrowski, and this organic chemistry video provides an introduction to nucleophilic substitution reactions. The next slide here is going to talk about the polar carbon-halogen bond and how it's really important for dictating the reactivity of alkyl halides. So here's a generic alkyl halide that's shown with a carbon group that's partially positive bonded to some type of halogen X, which could be fluorine, chlorine, bromine, or iodine, but this polar bond is important for dictating the reactivity of the molecule. So the carbon attached to the halogen is electron poor. So the carbon here has a partial positive that's indicated by this delta plus. And so electron-rich species like nucleophiles like to attack this carbon. So for example, this is a generic representation of something called a nucleophile. So a nucleophile is an electron-rich species. They oftentimes have lone pairs. Sometimes they have negative charges, but they're always electron-rich, and they like to take their lone pair of electrons and go and attack the partially positive carbon. And so the attractive force is the negatively charged nucleophile trying to get close to the partially positive carbon. This leads us into the next section, which deals with an introduction to nucleophilic substitution reactions. An electron-rich nucleophile likes to attack the partially positive carbon of the alkyl halide. So in substitution reactions, then the nucleophile will take the place of the leaving group. The halogen functions as a leaving group. It goes away and gets replaced by the nucleophile. Here's an example, a general example of a substitution reaction. So as on the previous slide, we've got our alkyl halide here with the partially positive carbon, the partially negative halogen, the nucleophile, which is electron-rich. And what likes to happen is here the nucleophile likes to use its pair of electrons to come in and make a new bond to the partially positive carbon, and then the electrons in the carbon-halogen bond go to halogen. So what I'm saying with this arrow is take this pair of electrons and make a new bond to that carbon. What I'm saying with this other arrow, this arrow right here, is take that pair of electrons out of this carbon-halogen bond and give them to the halogen. So we're going to be breaking this bond and we're going to be forming a new bond here. That gives this molecule where here's the new bond that we formed. This is the substitution product. The nucleophile has taken the place of the leaving group, and here the halogen, the X group, has left with a pair of electrons. This is the leaving group.